Industrial automation systems are built in layers like sensors, transmitters, controllers, PLC, and SCADA. Now let's understand how this architecture works. In the previous module, we have learned about industrial instrument selection method, where we discussed how to select the right instrument by analyzing application environment, range, accuracy, and installation. Now we will move to a very important concept in industrial automation, and that is industrial system architecture. Until now, we have been discussing individual components such as sensors, transmitters, controllers, and data loggers. But in the real industries, these devices rarely work alone. They are connected together to form a complete monitoring and control system. Today, we will understand how these systems are structured. Most industrial automation systems follow a common structure. The basic architecture looks like this: sensors, transmitters, controllers, PLC, and SCADA. Each component plays a specific role in the system. Let us understand each stage step by step. The first element in any measurement system is the sensor. The sensor is responsible for detecting the physical parameter. For example, a temperature sensor detects the temperature. A pressure sensor detects pressure. A humidity sensor detects humidity. And a level sensor detects liquid level inside a tank. However, most sensors generate very small electrical signals. These signals cannot always be used directly by control system. This is why the next component required is transmitters. Transmitter receives the signal from the sensor and converts it into a standardized output signal. One of the most common industrial signal is 4 to 20 milliampere. For example, a temperature transmitter converts the sensor signal into a 4 to 20 milliampere current signal. This signal represents the measured value. For example, a 4 milliampere may represent 0 degrees Celsius and 20 milliampere may represent 100 degrees Celsius. Transmitter makes it easier for industrial system to transmit measurement data over a long distance. Next in the system is the controller. The controller receives measurement signal from the transmitter and decides what action needs to be taken. Controllers are often used for process control. For example, if the temperature becomes too high, the controller may turn off a heater. If the humidity becomes too low, then controller may activate a humidifier. Two common types of controllers are there. First is on-off controller and second is PID controllers. Controllers help to maintain stable process conditions. Now step 4 is PLC. In larger automation system, control decisions are often handled by PLC. PLC stands for Programmable Logic Controller. A PLC is an industrial computer designed to control machines and processes. PLCs receive signal from many transmitters and sensors. Based on program logic, the PLC control equipment such as motors, valves, pumps, and compressors. PLC allow complex automation system to operate safely and efficiently. And step 5 is SCADA system. At the top level of the system is SCADA. SCADA stands for Supervisory, Control, and Data Acquisition. SCADA system allows engineers and operators to monitor the entire plant from central control system. SCADA displays information such as real-time sensor readings, equipment status, alarm conditions, and historical trends. SCADA system helps operators to understand the overall condition of the process. Let us consider a practical example. A pharma company needs to control the temperature inside a clean room. The system may look like this. A temperature sensor measures the room temperature. The signal is sent to the temperature transmitter, and the transmitter converts the signal into a 4 to 20 milliampere output. This signal is sent to a controller or PLC. The PLC decides whether to activate cooling or heating equipment. All the information is displayed on the SCADA system. Operators can see the temperature in real time and monitor system performance. This is typical industrial monitoring and control architecture. As an application sales engineer, your role is not only to sell individual instruments. You must understand how different devices work together. Customers often ask questions like, how do we connect this sensor to our PLC? Can we monitor this transmitter in SCADA? Can we integrate this system with our existing automation setup? If you understand system architecture, you can provide complete system solutions instead of just individual products. This builds strong technical credibility with the customer. In this module, we have learned how industrial automation systems are structured. The basic system architecture includes sensors, transmitters, controllers, PLCs, and SCADA. Each component plays a critical role in measuring, transmitting, controlling, and monitoring industrial processes. Industrial automation systems are built by connecting multiple instruments into a structured architecture. Understanding this architecture helps application engineers to design reliable and efficient monitoring systems. In the next module, we will move deeper into industrial problem solving, where we will learn how to design complete solution for a real customer applications. So thank you so much for watching. See you all in my next video.